So continuing here in 5.1 in Trig on exponential functions, we're now on example 5. This is just the exponential form of an equation. Your some number out in front of your 3 to the x plus c is all. That is your horizontal asymptote. Okay, that's what horizontally it's getting really close to but will never touch. Your a, that is your, let's see here what we have hidden. That has to be positive, so keep that in mind. And we have a problem here. It says suppose that the asymptote is y equals -2. The y-intercept is 6 and the x-intercept is 2. So how can we solve this? Well, here's what you do. The horizontal asymptote, that's what this is. So I know that that is going to be -2. So I know that c is -2. This is actually telling me more than you think. If the y-intercept is 16, that's giving me a point. That's telling me that the point is 0, 16. So what that's saying is, hey, plug a 0 in for x and plug a 16 in for y and try to solve this. Well, how can I solve this? It's actually very simple. A, the 0 is 1. So really I'm looking at b minus 2. So when I add 2 to both sides, I figure out, oh, okay, b's actually 18 in this problem. So now all I need to do is find out what a is. And the x-intercept is where that helps me out because that's telling me a point 2. The point is 2, 0. So it means I can plug in a 2 there and I can plug in a 0 there. So to find out what a is, I add 2 to both sides. So I get 2 equals 18, a to the -2. Divide both sides by 18 and I get 1/9 because it'll simplify. And all I did here was, remember, that's -2. We talked about this in the pre-rec chapter. The negatives mean that I move it. So if it was negative on the bottom, I'd move it to the top. But since it's negative on the top, I move it to the bottom. So really, I could just cross multiply here and get a squared equals 9. And I could square root them, figure out that I get plus or minus 3. Now since it can only be positive, that means it's only 3 as my answer. And there is the exponential equation for this problem. 18 times 3 to the -x minus 2. So graph 2 to the -x squared. Once again, don't make this any more challenging than it needs to be. To plug this in, go to y equals, because use the graphing calculator for this, 2 caret sign. Then you need a parentheses, and the reason why you need a parentheses is you need to put all of that, because that's all up in the air, in parentheses. So it's a -x squared, then end parentheses, and graph. And when you do that, if you go to second graph, you get a table, and there's your list of points. So there's -2 about 1/6 the way up, -1 1/2, 0, 1, 1 about half of the way up to 1/6, and there is your graph.
You can't keep running away from things. You gotta be tough.
So exponential functions can be used to describe the growth of a population of bacteria. Every day bacteria doubles. If 1,000 bacteria are present at the start, then you can figure out how many bacteria will be present with a formula that looks like this. You start with 1,000 and then it doubles every, let's say, every day, or growth of bacteria. I guess we don't know what T stands for yet, whether it's hours or days. But anyway, at time 0, right, if I plug the 0 in there, that's why it's 1,000. So after 1 day, we'll just say it's 2,000. After 2 days, it's 4,000. After 3 days, it's 8,000. And notice how it's just taking the old number and it's doubling it. So it should be 16. Next one should be 32. So the point we're getting at is whatever power it is will clue you in on what you get for an answer. Half-life, though, is the time it takes to decay. The time it takes the original item to get cut in half. So half-life is kind of the reverse, if you want to think about it.
Did you do a lot of paint chips when you were a kid? Why?
So, compound interest formula. You will use this formula all the time. Okay, this is a very popular formula as well. The compound interest formula. This is used by real estate agents just to find out how much you will have to pay over a course of a loan. The P stands for the principal amount of money that you're putting in. It's what you put in. Okay, it's what you're investing. A is the amount of money you'll owe after T years, and that's annually. R stands for rate, and rate is always as a percent, so you need to write that percent as a decimal. N stands for the number of times per year that you're going to calculate, and T is always in years. That's the number of years that you've been invested. So, suppose that $1,000 is invested at an interest rate of 9% compounded monthly. Find the new amount of the principal balance after 5 years, then after 10 years, then after 15 years. So, you're putting a rate of 9%, so that will go in as 0.09. You're putting in $1,000, so that goes in for P. The N, they're telling you that it's compounded monthly. Monthly means 12 times a year, so I'm going to put a 12 in there. And the first one says do it for 5 years, so I put 5 in. So all this is me just gradually simplifying it. You could plug this all in one shot on your graphing calculator, but what I decided to do is I put all that in to get 1.0075. That's to the 60. And then multiplied to figure out I get 1565.68. So what that means is I made about $565.68 on that investment after 1 year. What about after 10 years? Well, everything's the same. Nothing changed except that 5 is now a 10. So nothing changed here except that 60 is now 120. And over 10 years, okay, so over 10 years, since I put $1,000 in, I made about $1,451 is what I made, which isn't bad for 10 years, but that's only because I only put in $1,000. 15 years then, everything's the same, except now it's 12 times 15, which is 180, and I end up getting 3838.40. Well, remember I put $1,000 in, so 2838.40 is how much I made in 15 years.
Hot pot of coffee.
So, right. I guess we will continue on these problems when we come back. I don't want to get caught in the middle of this problem and not be able to finish it up for you quick. So when we come back here, we'll finish up on some more compound interest problems. And I will talk with you guys in a little bit.